Hello, Calc 1. My name is Reed. I'm a tutor from the Math Learning Center at SDSU. I'm going to help you through question 5 from your midterm. I also work at the MLC from 2 to 4 every Monday and Tuesday. So if you need help, you can swing by then. So let's start with drawing it out. So if I have a ladder against a wall, it would look something like this, 13 feet long. And it says Jerry tugs at the bottom of the ladder, sliding along the floorway at a constant rate of 2 feet per second. So we have, if this is like our x-axis, this is our y-axis, then this rate going away is going to be dx over dt equals 2 feet per second. That's not really writing, whatever. Okay. The other given we have is that we want to find the rate at which it's sliding down the wall. This would be dy over dt. And we want that when the bottom length here is 5 feet. Okay, so the first thing I see is that we're missing this y value right here. We don't have that variable. So to find out what y is when x is 5, we can use this equation. Okay, so by plugging in, our a here is going to be y squared, our b is going to be 5, so it's going to be 5 squared, and then our c is going to be 13. It's 13 squared. Solving for y, we can make this 13 squared minus 5 squared, and you should get 12. Okay, so we can erase this and replace that with 12. Okay, I'm going to erase the rest of this, except for this. So we're going to use the same equation to solve for dy over dt. So to do that, we're going to use, we're just going to replace a squared with y. So it's going to be y squared. Our b is going to be x, so it's going to be x squared. And our c is given as 13. That's never going to change because it's the ladder. Okay, so from here, if we take the derivative of this, we'll get dy over dt and dx over dt in our equation. So if we do that, we'll get 2y. Then we have to use chain rule, and since we don't know what y is, taking the derivative of it would just be this. And the same thing for x, so this would be 2x dx over dt. And then we take the derivative of 13 squared, it's just going to go to 0. Okay, so from here, we have some variables. We know y is equal to 12, so we can make this 2 times 12. We know we were trying to solve for dy over dt, so we're going to leave that as a variable. We know x is going to be 5. And we know dx over dt is going to be 2. And this is all still equal to 0. So if we solve for dy over dt, we'll get negative 5 over 6 feet per second. Okay, so we can say the speed, what speed is the top of the ladder sliding down the wall? We can say the speed going down the wall is 5 over 6 feet per second. Okay.